Before we get into our project, it's important to understand machine learning, which is the key concept of our research. So what it is, it's the method of achieving desired results using brute force, which is just keep trying until it works. And machine learning aims to recognize patterns from a large amount of data. And when we train it, it self-adjusts so that it's better at recognizing these patterns. And again, it has almost like limitless implementations from ranging from image stylizations to image recognition, speech recognition, encoders and decoders. It can range from anything really. This is photorealistic style transfer of WCT. And so photorealistic photo style transfer is an optimization technique used to modify the style of an image while still preserving its content. It usually takes two images, a content and a style image, and style transfer will blend the two pictures together so the output image looks like the content image, but have the style of the style image. So the actual content of the content image preserved, is just the styles added to it. And so this is implemented by optimizing the output image to match the content statistics of the content image and the style statistics of the style image, which are extracted from the image using convolutional networks. And the style technique we're using is WCT.
Autoencoder is an important part of the model. Autoencoder has two sections, an encoder and the decoder. The encoder takes in an image and produces a feature vector. As you can see in the graph, the feature vector is the compressed middle section marked in blue. The feature vector is a very small representation of the image that machine can easily interpret or mess with. Then the decoder takes in the feature vectors and reconstruct the image the best it can. In the later section, we'll apply the whitening and color transform to the feature vector. So after the modification, the reconstructed image will have the transformed features. The decoder can only reconstruct the image well if the feature vector has important features. This means the feature vector contains all the important information. So we'll go down, and this is the code for our pre-trained model. The encoder structure is similar to the VGG19 model. The decoder structure is an encoder but inverted. If we want to train the model, we will use the code below. So each epoch means going through the entire training data set once. In the example, we go through the entire training set 40 times because it says 40 epochs. In the real world, it can take more or less depending on how well the model learned and the data it's presented with.
And WCT is the module that we used in between the encoding and decoding to apply the style transfer. The goal of WCT is to directly transform the content image to match the covariance matrix of the style image. The complicated WCT transform is taking statistical information away from the content image and apply the styles images statistics onto the content. In other words, a smart way to take the information of the style and apply it to the content. It consists of two steps, widening and coloring transform. It's a linear transform that doesn't require any training. And here is a photo demonstration of the relation between the encoder, decoder, and the WCT. In the image, the C stands for the content image and S stands for the style image. They are being passed into the encoder. After the transform of the WCT, they go into the decoder and then gives out the output. And here's the code for the WCT. Again, it only applies linear transformation to the content image and it works without any training.
All right, and next we have the actual demonstration of some inputs. So first we will load the pre-trained models and have the encoder and decoder ready. And then next up, we can load the content image and the style image as shown below. So the content is the one with the tree and the style is the one with the boat. And next, the only thing we need to do here is we have the pre-trained model ready, and then we pass in these two images as input. And then we receive the output. And now it's shown below. So here we desire to have the style of the one with the boat applied to the image with the tree. And we can see the result here. And we can see the difference between the WCT result and the naive addition when we simply add the two images together. And below, the last one is the autoencoder output. And that's it. It's pretty easy and straightforward once you have the model trained. And here are some sources that we use. The paper with the core concept of WCT is the universal style transfer via feature transforms. And some similar applications of this paper is deep transfer, and the link is attached below. And also there is a newer version called WCT2, but since it has a lot of extra features applied to it, we decided to not do something similar to it. Since we are only showing the fundamental concept here in this project. That's it. I think so.